So good evening everyone. So last week we discussed about this Newton's laws, Newton's first law and second law. Today we have to complete the lesson. We can complete the lesson Newton's third law and the rest. Okay, so those who got absent last week, you can get the recording and complete the first part of this dude. So there are three laws of Newton motion: Newton's first law, second law, and third law. And then I explained about the relationship between the Newton's laws and the velocity time graph. And I told this equation is a bit important because you are getting calculation from this equation. You are getting calculation from this equation. Right. Now Newton's third law we had to start today. And I have shared with your WhatsApp group this friction lesson also, theoretic, but I'll be not discussing this today. So you can keep the printout or the hard copy ready, right? By next week. I'll be starting this next week. Okay. So under Newton's third law of motion, so what is Newton's first law? If I quickly summarize, Newton's first law is until you apply an unbalanced external force. So Newton's first law we have done, right? Done last week. So what is this? Until you apply unbalanced external force, objects in motion move with uniform velocity and objects at rest remain stationary until you make the forces unbalanced. Objects at rest remain stationary and objects in motion continue to move with the uniform velocity. So I explained that in detail last week. And then Newton's second law I told acceleration is directly proportional to the unbalanced external force and acceleration is inversely proportional to the mass. So this is called inversely proportional. Inversely proportional means when one increases, the other one decreases. That means when mass increases, acceleration decreases. So directly proportional means when unbalanced force increase, acceleration also increases. That's how you do it. Then by combining these two we get an equation. We call it F equals ma. What is the equation? If F equals ma. So this equation you have to remember for the calculation. What is F here? Unbalanced external force, m is mass, a is acceleration. So they will not ask how to derive the equation from the Newton's second law. So what is the equation we obtain from the Newton's second law of motion? F equals ma. So I'll give one example. Imagine if there's an object moving 1 kilogram of an object moving. So you apply here 15 Newton and this side someone is pushing with 5 Newton. What is the total now? So F will be total 15 Newton. So then mass, so imagine 1 kilogram. If you know the mass, you can tell the acceleration. 1 kilogram, then you can find the unknown one, acceleration. So acceleration equal F divided by m. Acceleration equal F over m. Is that clear? So F is unbalanced force, m is 1 kilogram. F is 15 Newton. F is equal to 15 Newton and m is equal to 1 kilogram, then 15 meters per square second. 15 meters per square second. Right. Then if you make the unbalanced force means imagine you make the force this side opposite direction, then what is the result? Imagine this way you put 12 Newton So then the unbalanced force will be 15 minus 12 Newton. So then we get the net effect 3 Newton. So then the resultant force will be 3 Newton actually, because out of this 15 Newton, so the 12 Newtons get cancelled. So at the end only 3 Newtons left, 15 minus 12, then 3 Newton. So the resultant force is 3 Newton toward this direction. Then to this equation you have to apply 3 Newton here. So you have to put here 3 Newton. So always remember this should be what force? Unbalanced force. So F is unbalanced force. Sometimes we call it resultant force. What is F here? Unbalanced force. F is unbalanced force. Unbalanced force. Understood? Right. Okay. Right, now let's see Newton's third law. So today we will start with this Newton's third law. Right. What is Newton's third law? So you can see the textbook. So they have given for every action there's an equivalent action, there's an opposite and equal reaction. That is the Newton's third law. So I'll explain that. I have given many examples for this. Right? Now you can see here in the tutor I have given many examples. In our day-to-day life, practical applications of Newton's law. So first let's write Newton's third law. Right, Newton's law, right? For every action, there's an equal and opposite reaction. For every action, come on, there is an equal and opposite reaction. There's an equal and opposite reaction. Equal and opposite reaction. Please highlight in this equal word highlight, opposite word highlight. Equal word highlight, opposite word highlight. Action highlight, reaction highlight. So that's very important. For every action there's an equal and opposite reaction. For the action and the reaction. So what are the two things here? Action and reaction. They are equal and opposite. Look at the first one. So if you take rebounds in a ball on the wall, right, or on the floor. So one example you can write the first thing. When you release rubber ball on the floor, it rebounds. Rebounds in one example you can write the first example, right? Rebounds in a ball on the floor or on the wall. Rebounds in a ball. That is due to the reaction. According to the Newton's third law. Rebounds in a ball due to the Newton's third law. And the other one, sending a rocket. Now let's see how to analyze the action and reaction here. Now when you release the ball, so the action is the ball on the wall. So there's a force. So please mark the action here. So when you release the rubber ball to the ground or to the floor, so the force is exerted on the wall. That is the action. And ball rebounds. The ball rebounds due to the reaction. Ball rebounds due to the reaction. So you can write ball rebounds due to the reaction. If you only write that near this, ball rebounds due to reaction. So equal means what? If the action, okay, what is the meaning of equal? Equal means if the action equals say 10 Newton, then reaction also will be 10 Newton. That's the meaning of equal. Both are equal in magnitude actually. Equal in what? Magnitude. You can write that. If action is 10 Newton, then reaction also will be how many Newton? 10 Newton. Reaction also will be 10 Newton, and they are opposite. Action forward, reaction backwards. So that is what the Newton's third law describes. So if you can mark that with a pencil, example, if action is 10 Newton, reaction also 10 Newton, equal, and they are opposite in direction. Then the other example, this force, the sending a rocket moves up due to the reaction. Rocket is moving upwards due to reaction. So actually you can mark here force. Now large quantity of fuel burned before sending rocket to the space. So this direction backward, this force of large quantity of gas sent towards the earth, that is the action. You can highlight, it's already there. That is the action here. This is the action. What is the action here? The force exerted downwards by the gases burn. Then the reaction is upwards. So the rocket is moving up due to the reaction. Without the action, no reaction. If you make more action, more reaction. If you take less action, less reaction. So they are equal and opposite all the time. So they act as pairs. Imagine when kicking the ball. Okay. So imagine football or rugby. Force, the ball is moving towards the feet. That is the action here. So the action is ball. You can see here the force. Now you kick the ball, that is the action here. So this red one is action. You kick the ball. This is the action. So reaction also, the ball also going to hit your, going to make the same force towards your feet. Sometimes you get some pain, joint pain because of the reaction. Reaction on the shoes or on the feet. Reaction, or if you want to write action on the ball. Reaction on the feet. You can mark that. Reaction is on the feet. Action on the ball, reaction on the feet. So here also what? Action on the wall, reaction on the ball. Reaction on the ball. Action in actually action on one object, reaction on some other object, not on the same object. So action and reaction both won't act on the same object. This is very important to understand. Action and reaction both won't act on the same object. Action on one object, reaction on the other object. Example, action on the floor, reaction on the ball. Action on the floor means the force exerted on the wall or on the floor by the ball. Action is done by the ball on whom? On the wall. You are throwing the ball towards the wall. If you throw the ball, rubber ball or whatever the ball towards the wall, so action is by the ball on the wall. On the wall by whom? By the ball. That is the action. Reaction is what? In return, the ball is hitting. Imagine if you are hardly from your palm, if you are hardly hitting the wall, using your hand, if you are hardly hitting the wall, so definitely you get a pain. Why? That pain is due to the reaction. If you are hitting someone, you also get some pain to the your feet or whatever the palm. That is due to the reaction. That is due to the reaction. Okay. Then sometime what happen? You are if you take a stick and if you hammer into a large concrete slab with a stick, wooden stick. If you hardly hammer into a concrete slab, what happened? Sometimes the wooden stick will crack or break. That is due to the reaction. That is due to the reaction. Car crash. Sometimes the wall also get damaged. That is due to the action, because wall is not moving. Wall is at rest. Maybe the wall means maybe the house, or maybe the wall around the house, around the garden. So wall is not moving, wall is at rest, but the vehicle is moving and knock on the wall or knock on the tree. So the wall also can get damaged. That is due to the action. Vehicle also get damaged. That is due to the reaction. If two vehicles collide in each other, collision between two vehicles, both the vehicles get damaged. Not only one vehicle, actually that is because of the action and reaction. One vehicle get damaged due to the action, the other vehicle get damaged due to the reaction. So that's how it happens. Okay. So they always act as pairs, right? Action and reaction, they act as pairs. I'll erase the screen. So you had enough time to copy it, right? Now there's one more example. You can see here now when shooting, right? So you make the force is exerted forward, but again in return there will be a force acting backwards. That is due to the reaction. That's why you need sometimes you also will be thrown out backwards due to the reaction. The action forward, reaction backward on your body. Action on the by the action by the whatever the weapon, reaction backwards on your body. So that's why you need to stand. You have to be balanced on the floor, otherwise you also will collapse. I mean, you also will be fallen on the ground. So this cap is gone up because of that, right? The next one, send in a balloon, right? So sometimes we send air-filled balloon or weather balloons. So what happened if you remove the knot here? Now you can see air is blown out. So air out, air is sent out. That is the action. If you release the knot, if you release air from the balloon, but that is the action. Air out, that is action. And balloon is moving up due to the reaction. This is the reaction. So action downwards, air is you open the mouth of the balloon. When you open the mouth of the balloon, air is sent out. Air sent out with a greater force. That is the action. That is the action. Air sent out from when you open the mouth of the balloon. Air sent out when you open the mouth of the balloon. That is the action. That is the action. And the reaction upwards, you can write here the balloon is moving up due to the reaction. Air-filled balloon moving upwards. This balloon is if you want similar observation, you can tell skycrackers, ahaskuru, the same observation, same scenario. Right? So you can write here balloon moves up due to the reaction. Due to reaction. Reaction is balloon is moving upwards due to reaction. So to get the reaction, you need to action. Without the action, no reaction. You have to make an action to get the reaction. Due to reaction. Now the similar example you can write. Send in skycracker. Ahaskuru, like I don't know, they have seen this skycracker. Skycracker. I don't know how many of skycrackers. Same technique. Skycrackers also, the skycracker is moving up due to the reaction. So when when you burn this, the skycracker action is downwards. So here the action means, so the downwards action, the skycracker is moving upwards due to reaction. Is that clear? There are many examples. Don't know which example they'll give in the exam. They can give different situations. The skycracker I have not given in your tune, but you can write it separately. I have given nearly 9 examples. You can add one more example like this. Okay, skycracker. Then next one, I'll erase the screen. Number 6. So swimming. So now actually the action on the, you can write here, action on water. Action on water. You make the action on water. Reaction on your body. So you can swim forward due to the reaction on the body. You are pushing water backwards. And water is pushing you forward. Do you understand what happened in swimming? So you make the action on water. You make the action on water. Action on water from your palm, like from hand. Hand make the action. That is the action. Try to understand the action and reaction. Hand push water, that is the action. And water is pushing forward. Sometimes have you all seen similar one? The steamboat. Like sometimes this toy steamboat. You have a engine boat even. Engine boat. It's engine here. So this is an engine boat. Engine boat, the engine is pushing water backwards. So engine is pushing water back. And the boat is moving forward due to the reaction. So the engine makes the action backwards on water, and water is pushing the engine boat or the steamboat forward. So therefore engine boat is working according to the Newton's third law. So you can swim forward by making the action on water. If you are not moving your hands, you will not move forward. You can't swim. You will get drowned. So all these are under Newton's third law. So sometimes what happens, before you start the 100 meters race, so even I'll erase this, you can mark these things with a pencil. Action on whom, reaction on whom. What is the action, what is the reaction? So what is common among this about this action and reaction? They are equal, action and reaction equal, and they are opposite in direction. Next one, number 7. You make the action on water, action on the ground. You make the action on the ground. Right? That is the action. Action you make on the ground and reaction on your feet. So otherwise, before starting the marathon, or you can write, say, an event, Olympic event, 100 meters race or marathon. So you have to make the good start. To have a good start, you have to make action with the signal. The one who make the action immediately after with the signal, action with the signal of the pistol, action with the signal given, then you can move fast forward. Some people make the action before the signal, so then again you have to start the event from the beginning. Some people make the action after the signal, so they are too late. The people, those who make the action on the ground, if you are just standing on the ground and running, then your starting is not good. So you have to push the ground backwards from your feet or from your shoes. You are making the action backwards on the ground, and you can move fast forward with a good start. You can move forward due to the reaction. So your starting is good if you make the action with the signal. Immediately parallel to the signal you make the action. Some people, there will be a delay, so the thinking time, it takes some time to reach the sound of the pistol given for the signal. a signal is given by maybe a small pistol or something, or maybe like a sound you get, the signal that travels to your ear tube, to your ears, and then from ears to your brain, and from brain to your legs, the signal. So therefore it takes some time. We call it thinking time. Some people, the thinking time is more. Drunken people, thinking time is more than at the normal time. That's why the drunken drivers, so higher risk of accidents. The reason is actually drunken drivers, they take more time to apply brakes, but they drive at high speed. They don't feel the speed. Drunken drivers drive at high speed, but in the sight of an accident, it takes more time to take the decision. So that means thinking time is more. So then what happened, before they apply brakes, though it will knock on the person or the other vehicle. So those things are very, very important to understand. Next one, number 8. So rowing. So you make the action on the water by the pedal. Okay, so we'll continue. There are many students in the waiting room. Okay, right. I think even I am experiencing the power cut, and so you'll bear up with me because these routers and all not working. So with the mobile connect, the hotspot. With the technical issues, so you had bear up, because anyway at this time I am also experiencing the power cut, and some of the students also might experience this. But anyway, I don't cancel the class due to those issues. Anyway, we'll have to manage that also. We can't avoid those things, right? So then so what is rowing? So when rowing, what happened? You make the action on water. Action on water. By whom? By this paddle. Reaction on the actually on the boat, or you can write, say whatever the paddle reaction. They have given this in your textbook also. Okay. So force is applied on water. Action is force applied on water. Force applied on water will be the action. Without the action, you don't get the reaction. So the boat is moving forward due to the reaction. Right here, the boat is moving forward due to the reaction. Reaction. So that is by rowing a boat. You can write rowing a boat. What applies, which principle of physics is applied when rowing a boat? That is Newton's third law. Okay, so I have got 2 examples of swimming. So here this is action. Action on water. Reaction on the body. Reaction is on the body, so that's why it's moving forward. Action on water. Reaction on the body of the swimmer. On the body of swimmer. Right. So therefore he can move forward due to the reaction. So he can swim forward due to the reaction. If you make the action much with a greater force, you push water backwards with a greater force, you will get the reaction also greater. So that means you can swim fast. You can swim fast. Right. So that is by a reaction on the boat. On oars. OARS, oars, nice, the paddle over. On oars by water. Here, like, I mean under the rowing a boat. Rowing a boat, swimming. What are the example? Rowing a boat, swimming. Then what is called sending a rocket or sky crackers. rebounds in a ball on the floor. Those are many examples for what are all these? All these Newton's third law. What is Newton's third law? For every action, there's an equal and opposite reaction. So in the exam, they will not ask calculation. So under which part you are getting calculation in the exam? Under Newton's second law. What is Newton's second law? Acceleration is directly proportional to the unbalanced external force, and acceleration is directly proportional to the unbalanced external force, and acceleration is inversely proportional to the mass. Right? Acceleration is inversely proportional to the mass. Right. Right. So then let's move on to the next part. That's all the examples, but there are many other examples you can give. Okay, I'll erase the screen. Next one, properties of action and reaction. So what are the common properties of action and reaction? Equal in magnitude. What are the common properties of action and reaction? Action and reaction, they are equal in magnitude, right? Equal in magnitude. Equal in magnitude. Magnitude means what? The value. That means if action is 10 Newton, example, you can write example if you want. What is the equal in magnitude means? If action is 10 Newton, the reaction also 10 Newton. If action equal 10 Newton, the force, the magnitude, then the reaction also will be 10 Newton. If action is 10 Newton, then reaction also equal to 10 Newton. That's how you do it. Then next one, number 2, opposite in direction. Opposite in direction. Opposite in direction. They are opposite in direction. Opposite in direction. Yeah, opposite in direction. Equal in magnitude, opposite in direction. And next one, you can write one more property. So they act as pairs. They act as pairs. They act as pairs. That means only action not possible, only reaction also not possible. So if there's an action, there will be a reaction. Therefore they act as pairs. They act as pairs. Then action act on one object and reaction act on the other object. They don't act on the same object. They don't act on the same object. If action act on one object, reaction will act on the other object. Action on water, reaction on the body, something like that. So both will not act on the same object. Action on one object and reaction on another object. Reaction on another object. Reaction on another object. Okay, next one. So what are the common properties of action and reaction? They are equal in magnitude, they are opposite in direction, they act as pairs, action on one object and reaction on another object. An action is exerted by one object and reaction is exerted by, that also you can write if you want as the fifth one, but anyway only 4 is enough. Right. Then so if you take, I'll give one example. If you take a pen tube, look at the screen here. You can make a small this. You can take a small ballpoint pen, the tube, like without the ink, like you have a ballpoint. Here you have, or else you can have a straw here for drinking water. Drinking the straw for drinking drinks or the fizzy drinks. We use a straw like this. And then you can have a inside, you can have a wire or something like that, because once the oral paper, the provincial paper, western province paper, they ask a question like this. So then you can attach this to two ends. You take a straw and have a thread or ring like this. You fix this to two ends so you can hold it, and you fill a balloon. You fill a rubber balloon, you inflate and attach this with masking tape. Because you better copy on this, they can ask this in the term test paper. You tie up this with a knot. So the balloon filled with air. A balloon filled with air. A balloon filled with air. And here you have a pen tube. A balloon filled with air and a pen tube. Or you can have a straw. Pen tube or a straw. And then you have a string here. A string or a wire. You have to stretch the wire or rubber band. What happened when opening the mouth? You can open the so how to start this? By opening the mouth of the balloon. Open the mouth of the balloon, or release air by opening the mouth of balloon, or release the knot. Open the mouth of the balloon and release air. Open the mouth of balloon. What happened now? What will be the action now? What will happen? Okay, who can tell me if I open the mouth of this is filled with air? Any volunteers who can tell me the answer? If you open the mouth of the balloon, air is blown out from the mouth of the balloon, this direction. So the balloon will move this with the straw. There is a straw, it can freely move forward and backward. The straw can freely move because there's a cavity inside. The straw or the pen tube can freely move forward and backward. In which direction this balloon and the straw is moving? Any volunteers who can tell me the answer? Yes, okay, Sohana, yes.
To the right side.
Yeah, very good, Sohana. The balloon is moving towards the right side. That is due to the, okay, so this is the action. Action is the action this side. Action is here. So the reaction will be what? Reaction, you have to mark in this direction. That means the balloon and the straw is moving in this direction. That is the reaction. So actually a balloon is moving towards the right side due to the reaction. So once in the Western Province paper they gave this question. They gave this diagram and asked this question. If you want, I'll share that with you, the paper, Western Province paper, grade 10 provincial papers, grade 10 Western Province paper. grade 10 first term test. I'll raise the screen. I'll show you grade 10 first term test, Western Primes. grade 10 first term test. I'll discuss that paper with you one day. I'll share that with you. I'm going to start the paper class from May. Most probably I'm going to start the paper class from May. It's not second term test. It's I think 2018 first term test, as I remember. Yeah, I'll discuss so in the future. Yeah, that one. Right. I think this one. Wait, I'll show you the paper. That is the paper, okay, Western Primes paper. I'll share this with you with your group when I discuss the paper class, right? You can see there's a question they have asked here. Structured essay, question number 4, as I remember, structured essay, question number 4. This is the one. Can you see the screen here? This is the Western Primes paper, the question, the one that I explained now. So this is from the Newton's third law. Newton's third law. Who can guess the answer or write two observations that can be seen when the thread holding the mouth of the balloon is loosened? So if you remove this thread, any volunteer, so I just tell me the answer. What would be the answer for this? So if you any volunteers? What is the answer for the part 1? What is the answer for the part 1? Two observations. What are the two observations? One observation. When you open the thread of the balloon, one observation who can give me? This is Western Primes first term test. So remember, 25% of the structure is a compulsory questions. 25% of O-level science paper structure is a compulsory questions. O-level science paper structure is a 25%. From structured essays, you get from practicals like practical based questions, activity based questions from practicals. This is very important to understand. Right? So what is the answer for this? Two observations that can be seen when the thread holding the mouth of the balloon is loosened. Yes, who can tell the answer for the part 1? Yes, this you can see this is the Western Primes paper. This is the Western Primes paper here. 2019 first term test. I'm going to start the paper class from next month, then I will share this with your group and I will discuss in the whole paper, but just to understand the Newton's third law, the type of questions they could ask. Yes, any volunteers? What are the two observations when you open the thread of the balloon or when you open the mouth of the balloon? Common sense. Don't think too much. So what do you observe? Observe means whatever you observe through your naked eye. Yes, any volunteers? Yes, Badika? Yeah, you can tell the answer, Bas.
The balloon means from
strings. Anyone else? Any other alternative answers? One observation, size of the balloon decreases. One observation will be what? Size of the balloon decreases. Oh, air is blown out. Air is blown out. Okay, right. Balloon is moving in the opposite direction. balloon and the tube of the ballpoint pen is moving towards the right side. So what is the observation? Or you can write balloon is moving towards the right side. Balloon is moving towards right side. That is also possible here. Understood? Right. So like that they can ask questions. So they ask here which Newton's law related to the motion of the balloon in this activity. Name the Newton's law related to the motion of the balloon in this activity. What is the law? Newton's third law. They don't directly ask you to write the Newton's third law. Answer is Newton's third law. Newton's third law. From this activity, Newton's third law. They are asking you to using arrows direction of the movement of the balloon and the direction of the release of air. They ask you to mark. So the answer for the part 2 now. They ask you to mark the so this one. The answer is what? Direction of the movement of air. So this way. Direction of the movement of the balloon is in this way. So you have marked this separate. Direction of the release of air. This is the movement of balloon. Is that clear? Right. Then, so now this is just to have an idea that whatever questions you might get, then so they ask you about name another situation or phenomena that you observe this in everyday life. So you can write send in a rocket, send in a skycracker, swimming, rowing a boat. Many other examples you can write. Any already know answer. What are the another situation where this phenomenon is Newton's third law? Row in a boat, send in a skycracker, send in a rocket. Like in everyday life you can write swimming, row in a boat, or rebounds in a ball on the floor. Then I'll explain how the motion of this balloon. Before that, there's one more thing they asked here. How can you increase the speed of the balloon? How can you two changes that can be done to increase the speed of the balloon. Two changes that can be done in order to increase the speed of the balloon. In order to increase the speed of the balloon. Yes? Volunteers? Anyone can suggest? How to increase the speed of the balloon here? One time modification. One thing you can write, but you can apply some grease or oil on the thread or the wire because it's more slippery. And the other one you can use a straw instead of ballpoint pen. Your ballpoint pen is heavy and you can use a straw. You can fill more air into the balloon. You can fill more air into the balloon, increase the pressure inside the air pressure inside the balloon by blowing more air into the balloon, or you can use you can apply grease or oil on the wire, and you can use instead of tube or ballpoint pen, you can use a straw. Or else you can do this also. You can keep this in an angle, like slightly inclined, like this, slightly inclined. Right? You can keep the wire or the thread slightly inclined, like that. Okay. Then next one, number. Okay, let's move back to the again. Right. So that's about the Newton's third law I gave. So now calculation from this, just you should know the law, the definition, and next one example. If they give an example, you should know how to write it, and action and reaction, how to identify the action and reaction of a given example. You should know. Right. The next one, the last part of this lesson. After that, this lesson is over. Momentum. It's very important. I am showing the textbook. Also, they have given the textbook this momentum. Okay, so this is the one that we discussed now. air is leaving the balloon and the balloon is moving in the opposite direction. So this is given in your textbook, page number 91. Page number 91 in your textbook. If you only can mark with the pencil here the action. So you can mark here, they are not marking. This is the action here. So textbook page number 91. The action, and this will be the reaction. Reaction is here. Reaction is here. So air leaving the balloon is action. What is action here? Air leaving the balloon. Air leaving the balloon. So reaction will be what? Balloon is moving towards right. Balloon is moving towards right side. Towards right side. Opposite direction. That will be the reaction. So this is according to Newton's third law. So not draw this. I have given this in the theoretic as well as it's there in the textbook. Done. Okay. I'll erase this. Then last part, moment. Let's see what is moment. Momentum. So what is momentum? It is a measure of how difficult to stop a moving object. A measure of how difficult to stop motion of a body. A measure of how difficult to stop a moving object. Okay, how difficult to stop, but how difficult to stop depends on what? Depends on how I'll underline this. How difficult to stop. This depends on the mass and the velocity of object. This depends on what? Depends on how difficult to stop depends on the mass of the object moving and mass and velocity. Depends on what? Mass and velocity. Mass and velocity of the object. How come? Mass is what? I'll give one example. Let's see mass here. By a huge rock is moving, say landslide or earth slips. Can you put your hand and stop the moving object? Stop this. Okay. Depends on the mass and the velocity of the moving object. Look at the screen, everyone. I'm making a huge rock. It's moving towards this house. Can you stop this? Cannot. So example, landslide. Landslide or earth slips. Say landslide or earth slips. Landslide or earth slips. Cannot stop. Cannot stop. Why? Due to greater mass. Cannot stop due to not. It's moving slowly but cannot stop. It is moving down slowly. Moving slowly. This low speed, moving slowly but cannot stop. Cannot stop due to greater mass. Due to greater mass. So it's very important to understand this. Therefore, what matters here not only the moving slowly but cannot stop due to greater mass. But cannot stop due to greater mass. But cannot stop due to greater mass. Is that clear? We cannot stop this due to greater mass. Understood? So it's moving slowly, low speed, therefore it has high momentum. High momentum is very difficult to stop. So this the moving huge mass of rock, maybe those areas during rain season. Sometimes the entire house get covered by large quantity of soil and rock. So has high momentum. So this moving rock over the slips or rock has high momentum due to greater mass. Has high momentum due to greater mass. Opposite of this, a bullet fired from a gun can be stopped. A bullet fired from a gun can be stopped. A bullet fired from a gun cannot be stopped. So you can write. That is one. This is number one. This is number one for situation due to mass. I told two factors affecting. One is mass, the other one is velocity. Now the mass I explained how that will affect the momentum, how difficult to stop due to the greater mass. Number two is bullet fired from a gun. It is difficult to stop a bullet fired from a gun. Not due to the greater mass, due to high velocity. It is difficult. You better copy down these things in your writing book, right? Because it's not given in your textbook. It's not given in your textbook. A bullet. It is difficult to stop a bullet. A bullet fired from a gun. A bullet fired from a gun or from a pistol. Due to what? Due to the mass, due to velocity. Due to its, it is difficult to stop a bullet fired from a gun due to velocity or due to mass. You can tell me the answer. Due to its high velocity or due to its greater mass. It is not that heavy, right? You can not like a huge rock or a landslide or a slip. So it's not. It's low in mass. It's not heavy, but it's difficult. You can pass through your body due to its velocity. Due to its velocity. So therefore, momentum depends on two factors. Momentum depends on two factors. Depends on two factors. So actually, momentum is equal to what? Product of mass and velocity of the object. Momentum is the product of mass and velocity. Momentum is the product of mass and velocity of the object. So therefore, if one of this zero, then the momentum is zero. right, before you complete the theoretic note, I want you to understand the concept, this concept momentum. So imagine now, if mass is zero, then momentum will be zero. Right? If imagine if velocity is zero, then also the momentum will be zero. Who can tell me an instance momentum becomes zero if something which is moving, it has velocity but no mass is zero. Tell me an instance, therefore the momentum is zero. Zero into velocity is zero, zero into something is zero. That means no mass. Anyone else who can tell me? Momentum is zero because it mass zero. What is moving? Something moving which without any mass. Can you guess? Who can tell me something that is moving without any mass, without any weight? Now also it's there around you. Now also definitely it's there around you. It's coming from the screen that you are using. What is that? At least now I give a clue also. At least now you can guess. Yes? Okay, who raised the hand? Swana, yes, Swana?
Yeah.
Yeah, actually, yeah, made of gas molecules. Gas molecules having mass, Swana. Because related to helium, hydrogen, oxygen, they have mass because you learn about the mass number. I mean, what is called protons, neutrons, electrons. So they have a mass. Protons, anything is made of, yeah. Not actually gas. Gas having a mass. Gas made of molecules, particles. Yes. Okay, what is coming out from your screen? Whatever laptop or mobile phone, what is coming out from your screen? What reached your eyes from the screen that you're using now? At least now tell me. From the you switch on the light, right? What is the source of light around you? Tube light, or lamp, or CFL, or LED. What is coming out? Light has no mass, but is moving. Light travels at high speed. Light of the sun reaches to the earth. Light velocity is what? 3 into 10 to the power 8 meters per second velocity. It has very high velocity light. Light travels fast, but mass is zero. Mass is zero. Can you tell I am receiving 1 kilo of light from the lamp? Can you tell I am receiving 2 kilos of light to my head? No, you can't tell like that. So therefore what? If you take the momentum of light is zero because light has no mass. Understood? So imagine now you are sitting on the chair. So what is zero? Your mass or velocity now? Your velocity is zero, therefore you don't have a momentum, you are not moving. If the object is not moving, it has no momentum. If the object is not moving, it has no momentum. Well, that means velocity is zero. Zero, your mass is not zero. Maybe 40 kilos or 50 kilos or 30 kilos, you have a mass. So mass is not zero, but velocity is zero if you are not moving. But if you are running 100 meters race, if you are walking fast, then you have a momentum. So momentum depends on the mass and the velocity of the moving object. If mass zero, then momentum zero. If velocity zero, then also momentum zero. Is that clear, everyone? Understood? Okay. I'll anyone still copy down? Any of this? Now please raise the hand. I'll erase this now. Finish? Right, done. I'll erase. So let's complete the theory two now. Okay, what is momentum? So actually momentum is defined as the mass of product of mass and velocity. Momentum is defined as the product of mass and the velocity of the object. Is that clear? Right now, momentum is defined as I'll write like this. Momentum is defined as the product of as the product of the mass. So mass, right, in that simple m, and the velocity of an object, product of mass and velocity v of an object. Right. So you can highlight here product of mass and velocity, highlight product of the mass and velocity, highlight product of the mass and velocity. You can write within bracket, it is a measure of how difficult to stop a moving object. It is a measure of how difficult it is to stop motion of an object. Within bracket, it is a measure of how difficult to stop object, how difficult to stop a moving object. Of a body. Yeah, often you have a question was okay, give me a second. This also yeah, often any question?
Sir, yes, sir. Sir, have you shared the tutorial?
Yes, you can't see the screen.
No, sir. I can't see.
Please raise the hand those who can see the shared the screen. Please raise the hand those who can see the screen. Please raise the hand those who can see the screen. Often like others can see, right? Something maybe if your internet connection is unstable, then you can't see. Please raise the hand those who can see the screen clearly. What I have shared now. Can see, right? Others, yeah, they raise the hand. Then okay. Again, I think you better leave and connect often again. Yeah. Because if one or two can see the screen, then others should be able. If none of you can't see the screen, none of you can see the screen, then there's a problem from my side. Okay. Right. So you can see the screen, right? Right. Then so let's see the equation. Yeah, I think now upon can you see the screen now?
So it's loading, sir.
Yeah, maybe your internet connection is unstable. Like if you have a low network band with then yeah. Right. You better get the recording now, no issue. So if you can request the recording after the class, send a request after the class. So write the equation for the momentum equal mass into velocity. Momentum equal m into v. Momentum equal m into v. M into v. So m mass, v velocity. Momentum equal m into v. So write m for mass, v for velocity. in kilogram. M is mass in kilogram. And v velocity ms minus 2. V velocity ms minus 2. You write the simple equation in the exam. Velocity must be in ms minus 1 velocity. So therefore unit of momentum is what? Kilogram ms minus 1. So that is simple. Here we can get kg ms minus 1. So what is the SI unit of momentum? kg ms minus 1. And write one more thing everyone, ms minus 1. Ms minus 1. And put a stand right. Put a stand right. Momentum is a vector. Right everyone? Momentum is a vector. It has a direction. Momentum is a vector. Momentum is a vector. Vector means it has a direction because of the velocity. We had done right. I am not going to explain these vectors and scalars from the beginning because we had done this under chapter 2, under unit 2. Momentum is a vector. Right. So the equation, very, very important. Please put 3 stars for the equation. Three stars for the equation. So then let's see what is this. There are some others. You can derive the equation for this momentum. Look at here. If the mass of the object, look at the screen everyone. If the mass of the object is m, that is the mass. M is the mass. Then u is initial velocity. U is initial velocity. V is final velocity. Final velocity. What is U? Initial velocity. What is V? Final velocity. So U is initial velocity. V is final velocity. And M is mass. M is the mass of the object. M is the mass of the object. Now, initial momentum is what? M into final momentum is m into final velocity. What is final momentum? M into final m into v. Final m into final m into v. Final momentum. Initial momentum is what? M into v. M into u. U is initial velocity. Mass into initial velocity. Initial momentum. Mass into final velocity. Final momentum. What is the change in momentum? Final momentum minus initial momentum. Change in momentum is final momentum minus initial momentum. 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 mv minus mu. So that's what I have given here. mv minus mu, that is called the change. Change is final minus initial. Yeah, this is my question class. Well done.
Sir, your screen has a delay.
Screen is not clear. Swana, can you see the screen?
No, sir, she's telling, I think you're not sharing the tute.
I'm sharing the tute. You can see the screen. This is the tute. I'm sharing now. Yes, open.
Yes, sir. We can see the textbook, sir, not the theory tute.
Really? Oh, okay. Wait. I'll stop sharing again. Wait. Can you see now? Can you see the screen now? Afan, can you see the screen?
Yes, sir, we can see clearly.
Okay, right. Okay, I think I had to explain. Did you all get this one? The what is known as momentum definition? You got right? Okay. Momentum. Okay, wait. I'll quickly write again. Momentum is m into v. I'll quickly write again. Momentum is mass into velocity. This equation you have to remember. Look at the screen, everyone. So m is mass, that is in kilogram. Mass in kilogram. V velocity in ms minus 2. The product of mass and velocity will be the momentum. Unit of momentum what? Ms minus 1 and kg. So that will be what? Kg kilogram ms minus 1. Then you get kg ms minus 1. Kg ms minus 1. That is the unit of SI unit of momentum. Then next one I told here you can label this. M is the, it's like, the mass won't change here. Initial mass or final mass is same m, right? Mass is m, and u will be the initial velocity. Initial velocity in this diagram. V will be the final velocity. So the final momentum will be what? Final momentum will be what? Mass into final velocity. Initial momentum will be mass into initial velocity. Right? So this is like final momentum is, look at the screen, everyone. Final momentum is what? M into final velocity. Initial momentum will be mass into initial velocity. Initial velocity, what is the symbol we use? U. M into U. Mu. So that's what I have given here what? Then therefore change in momentum will be what? Final momentum minus initial momentum is what? Mv minus Mu. Mv minus Mu. Then the rate of the, how to convert something into rate? If you divide the change in momentum by time, that is called the rate. If you divide this by time, that is called the rate. If you divide something by time, that is called the rate. Rate of eating, how fast you are eating, how fast something is done, that is called the rate. Rate means how fast that's happening, right? Now if you divide this by time, then you can take m out. If you take m out, then this part is, look at the screen, everyone. This is actually, this is not given in your textbook, but this is additional information. This v minus u over t is equal to what? Acceleration. So this is what we are done in grade 10 unit 2 acceleration. What is the equation? Those who are in the class unit 2, acceleration is equal to v minus u over t. So therefore in place of this you can put ma, that is F equals ma. So you can relate this to the Newton's second law equation also, F equals ma, because v minus u over t is equal to acceleration. V minus u over t is equal to acceleration. But anyway, no need to remember this, how to derive this. Derivation not necessary. Derivation not necessary. Right. Okay, shall I erase the screen? Anyone still copying down this? So basically what you have to remember, please put 3 stars for the equation of the momentum. Momentum equation, please put 3 stars. Very important. Momentum equation, please add 3 stars. And because you have to remember that for the calculation in the exam, they'll ask question from this definitely. And Done? Anyone still copying down? Done. Okay. Then next one, factors affecting the momentum of a body. So number one, right, first factor that affect the momentum, mass of the body. Mass of the moving body. Mass of the body or the object in motion. Mass of the body or the object in motion. Second one, you can write velocity of the moving object. Velocity of the moving object. Object or the body. Velocity of the moving body or the object. Velocity of the body or the object in motion. So you can highlight here the mass, highlight, velocity, highlight. Mass, highlight, velocity, highlight. Understood? Right. So that is the end of the theory section. That is the end of the theory part. Right. That is the end of the theory part. Now there are few questions I have given here. We'll discuss this. There are MCQs I'll discuss now. First, a few MCQs. Who can give me the answer for the first MCQ? Any volunteers? Please raise the hand. These are from the Newton's second law. Yes. What is the answer for this? What are the two main facts of the Newton's second law? Any volunteers? Who can give me the answer for this? Yes. Look at the theory note, the TUT or textbooks. What is the answer for this? Directly acceleration is inversely proportional and directly proportional. What is directly proportional to the acceleration? What is directly proportional to the acceleration? What is directly proportional? Acceleration is directly proportional to the unbalanced force. That is the first one. Second one is acceleration is inversely proportional to the mass. Equal number two is inversely proportional. That means what? Inversely proportional means when one increases, the other one decreases. When the mass increases, acceleration decreases. That is called inversely proportional. Directly proportional means what? When force increases, acceleration also increases. That's how you get it. Is that clear? Who can give me the answer now for the first MCQ? Can you all see the screen? Please raise the hand those who can see the screen. Right, okay, you can see the screen. Yeah, Afan, what is the answer? Ashini? Ashini Chavine, what is the answer for the first MCQ? You can post the answer in the chat. Yes, who can give me the answer? You can post the answer on chat, or those who can give the answer for the first one. You could not write the definition of momentum. Okay, I'll give it again. Don't worry, this are here. So definition is this: momentum is defined as the product of the mass and the velocity of an object. Momentum is defined as the product of the mass and the velocity of an object.
Sir,
Yes.
the answer for the first MCQ, fourth answer.
Okay. Fourth answer. Force is directly proportional and mass. Yeah, answer is correct. That is the answer. Very good, Afan. Answer is fourth. Force is directly proportional and the mass is inversely proportional. That is the correct answer for the first MCQ. Very good. Yes. Now, Tisavi, how many of you couldn't write the definition of the momentum? Okay, first one, the answer is this. You can write that in the mathematical expression. Number one is there are two main facts of the Newton's second law. What are the two main facts or the two conditions in the Newton's second law? Number one is acceleration directly proportional to the unbalanced force. Number two is acceleration is inversely proportional to the mass. So when you combine these two, that is called Newton's second law. When you combine number 1 and 2, that is called Newton's second law. Newton's second law. So directly proportional to the force and inversely proportional to the mass. Okay, let's couldn't write the definition for the momentum. Okay, if those who couldn't write this, so what is the definition of the momentum, right? Momentum is defined as the product of, right here, I'll write it again quickly, those who couldn't write, or you can request a recording even. Momentum is defined as the product. Momentum is defined as the product of the mass and the velocity product of the mass, you can write simple m, velocity you can write v. Velocity of an object or a body. Right, one more thing within bracket, it is a measure of how difficult to stop the motion of a body. It is a measure of how difficult to stop the motion of a body. This is how we done. Right? Okay. I'll highlight this, or the definition. If there's a definition, you write this. Highlight a product of mass and velocity. Highlight product of mass and velocity. Highlight. Right. So the equation you have to remember, right? So these are the two things. Definition you have to remember, and the equation you have to remember for the calculation. That's it. So those two you can highlight. Definition you have to remember the momentum, and the equation to calculate the momentum you have to remember mv. Momentum is mv. And right, I also write one more thing. What is the SI unit of momentum? M is kilogram, v is velocity ms minus 1. Then the unit will be kg ms, kilogram meters per second. Kilogram meters per second. Momentum is a vector. You can write here momentum is a vector. Understood? It is a vector. This is as a definite direction. Is that clear? Right. Now let's move on to the second MCQ. We discussed the first MCQ. Let's move to the second MCQ. Second MCQ. Who can give me the answer for this? This is from F equals MA. They are asking here, it's a good question, it's a past paper question. Which one has, the question is this. Which one has the maximum and minimum acceleration? Who has the maximum acceleration? How to find the acceleration? Look at the equation. What is the formal equation? F equals MA. F equals MA. Maximum, or so F equals MA. So then it becomes what? If you want to find F equals MA, if you want to find the acceleration, what? If it is F over M. Acceleration is equal to F divided by M. F equals MA is the formal equation. So if you want to find the acceleration, you can make this subject A equals F divided by M. Now we'll apply this. F divided by M for the first one. Capital A. What is that? F acceleration equal F divided by 2M. Right under each everyone. Here acceleration equal F divided by 2M. F divided by 2M. Here the acceleration is equal, B acceleration is equal to what? F acceleration equal F over M. So this is the equation. We substitute this. This is the equation, F over M. So right here A equals F over M. This one, what is C here? C is what? Acceleration equal 2F over M. 2F over M. Is that clear? So which one gives highest acceleration out of this? Which one gives highest value out of this? When you divide by 2 or when you multiply by 2? Yes? Who can give me the answer? Out of these three, which one gives the highest maximum acceleration? 2F over M, no? This will be the maximum. This will give the maximum acceleration. 2F divided by M. Maximum acceleration. This will give the minimum acceleration. Minimum and maximum. Then you can easily get the answer. Who can give me the answer? Those who have done this before me? Yes? Can you tell me the answer now? Everyone should be able to get the answer now. F over M in the middle. 2F over M you get higher value. F over 2M you get lowest value. What is the answer? Answer is highest C. Highest. So you get respectively. Highest will be C. Lowest will be A. Capital C and capital A. C and A. Answer will be C and A. Answer is 3. Please raise the hand those who got the third answer before me. Please raise those who got the third answer before me. Okay, how many are there? Right, very good. Very good. Right. Then, so this is a good question. You can put a star for this. You can get similar question in the paper also. Right. Okay, Tharul. Okay, good. This is how you write. Then next one. Question number 3. Who can give me the answer for the third MCQ? This is a velocity time graph. That is from grade 10 unit 2. Grade 10 unit 2. Grade 10 unit 2. From grade 10 unit 2. The graph represents the velocity of an object with time. According to the graph, any volunteers who can give me the answer for this? Please raise the hand or you can post the answer on chat. Yes? No one. So what is this graph for? This is constant or uniform velocity, right? This is uniform velocity. uniform velocity. This is called uniform velocity or constant velocity. So if velocity is constant, acceleration is 0. Look at here, the same velocity. So if you take here velocity 10, if you take y-axis, this the straight line, horizontal line, the velocity 10, what? Initial velocity also 10, after 1 second also velocity 10, after 2 second also velocity 10. That means that a equals v minus u over t. So final velocity also 10, initial velocity also 10. 10 minus 10 is what? 0. 0 divided by time 0. So acceleration will be 0 here. 10 minus 10, 0. Because here. Now if you take here, after 1 second velocity 10, after 2 second velocity 10, after 3 second velocity 10. So look at y-axis, the straight line 10, 10, 10, 10. That's no change. So therefore the answer is, it is at rest. At rest means what? X. Excellent. Okay, can you see the screen? Right, can, right? Okay, so the answer is what? Right. So that is the answer is what? Answer is second, right? Question number 3 answer is. Question number 3, what is the answer? Answer is most with 0 acceleration. Answer is second. At rest is correct if this was what graph? A displacement time graph. Please write everyone. At rest number 3 is correct if this was what graph? A displacement time graph. If it is ST graph, what you are saying is correct. S is displacement, T is time. Displacement in meters, time in seconds. If you get displacement time graph, it is at rest. Please mark this here, at rest. This is what? Velocity constant or uniform velocity. Uniform or constant velocity. And here the acceleration is 0. Acceleration is 0. Is that clear, everyone? Right, then next one. Question number 5. This is structured setup question. This is also a practical based question. Okay, before question number 5, question number 5 I'll discuss next day. Who can tell me the answer for this? Only 5 and 6. Question number 5. Yeah, question number 5 I'll discuss. Yeah, this is a practical. Yeah, that's important. Who can tell me the answer for this? So, how the trolley is behave when the external force is not applied? That means what? You don't hang this load. Before you hang this load, how the trolley will behave? So no load is hanging this side. The trolley will be, yes, any volunteers? It is at rest. It is at rest. Understood? It is at rest, so the trolley is not moving. Trolley is not moving. It is at rest because no external force applied on the trolley. So the answer for this will be at rest. Number 2. According to the figure, what is the magnitude of the force? Magnitude means a value. What is the force applied here? Look at the screen, everyone. What is the force applied? This is the force applied. 5 Newton force is applied. This is the force applied. 5 Newton. So the answer for this will be 5 Newton. Newton. Number 3. What is the change in position when the external force is applied on the trolley? Trolley is moving with an acceleration. The trolley is moving. When you apply external force, trolley is moving with an acceleration. Velocity increases. The trolley is moving with an acceleration. Trolley is moving with an acceleration. When you apply unbalanced force, until you put this load, it is at rest. When you apply 5 Newton load, it is moving forward with acceleration. It is moving forward with acceleration. Number 4. A ring has been fixed to stand on the rest. Stand to rest the load on it. What is the reason? What happens when this load is moving down and reach here? What will happen? What will happen? There's this thread. The thread is passed through this load. So then what happens? The load is resting on the ring. That means what? No tension, no force exerted on the trolley. When the load landed on the ring, if you want to write that near the diagram, when the load is landed on the ring, external force is removed. If you want to write that separately, when the load is landed on the trolley, external force is removed. So to remove the external force applied, why this ring is fixed? You can write here, when the load is landed on the ring, no, it will not remain rest, Tarul. The trolley now, it will slow down and come to rest after some time. It will not suddenly come to rest. Imagine one example, while you are driving the vehicle, you suddenly make the engine neutral. Will the vehicle come to rest? Tarul, I am asking this simple question. While you are driving the vehicle at high speed, you make the engine neutral. Will suddenly the car or the vehicle will come to rest? No, it will slow down and travel some distance and come to rest. Understood? That's how it happens. That's how it happens. So it will not suddenly come to rest. Is that clear? Right. So right here, when the load is landed on the trolley, external force is suddenly removed. When the load is landed on the trolley, external force is removed. That means no force, no more force. But the trolley, it had a big. I'll give one of the best example. When the while imagine you are in a school, like maybe in the bus or van, while the vehicle is moving, you suddenly jump out of the vehicle. Can you suddenly stand on at rest on the ground on the road? No. You have to move some distance forward. You have to run. Otherwise, you will be thrown out of the road. If you are jumping from a moving vehicle, you will knock on different objects, and you also, because at the time when you jump out of the vehicle, you also having the velocity. You also having the same velocity of the vehicle when you are jumping out of the vehicle. Therefore, you can't suddenly jump out of the vehicle and stand rest on the ground. So the same scenario here. While it is moving, you suddenly remove the force. It will not suddenly come to rest. Will not come to rest. So it will slow down and move forward maybe a few centimeters, and then it will come to rest. So what is the answer for this? It has been fixed on the stand to rest the load on it. What is the reason? To remove the force applied immediately. To remove the force applied immediately. This type of questions, compulsory questions, you are getting in the oral structure discipline paper. Compulsory questions, the practical based questions, right? Remember that. Right here, to remove the external force applied immediately. 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 Is that clear? What is the change in the motion of the trolley according to the answer given for part 4? What will happen to the motion of the trolley? While it is moving, you remove the external force applied. What will happen to the trolley? It will slow down and come to rest. The trolley will slow down and come to rest. What is the answer of the part 5? The trolley will slow down and come to rest after some time. Or you can write the velocity of the trolley decreases. The velocity of the trolley will decrease. The velocity of the trolley will decrease. Either one. So this one put a star for this type of question because there are practicals based. Under each lesson you get a practical part, right? Practical part. So that part you are getting many questions in the structure discipline paper, compulsory questions. Compulsory questions. Right. Done. Shall I erase the screen? Anyone still copying down? Anyone still copying down? Done, right? Okay. Now, number 6. After this, number 6. Force acting when the load is placed on it. What is the force? 0. You remove this, horizontal force becomes 0 Newton, right? So then this question is done. The last question only you have to try at home. I'll discuss that next day, the last question. And then I have already today I shared a new tutorial WhatsApp group, right? The last question I'll discuss next day, question number 6. This one for homework. Please mark this for homework. This question you can mark for homework. This is for homework, right? This is for homework. And this one I am going to start the new lesson next week, right? Friction lesson, grade 10 chapter 5, friction. Here is the textbook, this one. And then if you have not got the textbook, please send a request. I'll forward the PDF. I'll share with your WhatsApp. And I share this. This is the tube. So this theory tube I'll be starting this next week. And anyway, the paper class from next month will be discussing unit wise revision again from grade 10 chapter 1. From grade 10 unit 1 itself, we are doing last 30 years all the essays and structured set of questions. Paper class, so most probably that will be either Saturday or Sunday, Saturday evening or Friday evening. Paper class, grade 10 paper class from next month, right? I'll send a message at most probably we'll be doing Friday 6 to 8 or Saturday 6 to 8, right? Okay, then it's almost 8 o'clock. We'll stop for today and we'll continue the rest next week. Have a good night and God bless you.